Welcome to the spoken tutorial on creating a material stream in DWSIM. My name is Kannan Moggalya. In this tutorial, we are going to learn how to select chemical components, how to choose a thermodynamic package, how to choose units and values, and how to specify a material stream. To record this tutorial, I am using DWSIM 3.4 Windows version, but this process is identical in Linux, Mac OS X and FOSSEE on ARM. To practice this tutorial, you should have access to DWSIM. Let us start with creating a new steady-state simulation. When DWSIM is opened, you see a startup window such as this. Click on Create New Simulation. If a simulation wizard appears, cancel it. On the top left, locate a field called Simulation. Hover the mouse over the puzzle-like button next to it. You can see that it is known as Configure Simulation. Press this button. A Configure Simulation pop-up opens. In some earlier versions, this pop-up opened automatically. The lettering is very small and unreadable in this recording. To address this, I will zoom in on the relevant portion of this screen only. I have now rearranged the screen for better readability. In the Component Search tab of this window, type benzene. Benzene appears in 2 rows. We are interested in the entry that has DWSIM as the database. We will explain in another tutorial the significance of other databases. Double click anywhere on the slide. You could have pressed the Add button also, which is on the right hand side, which we will see shortly. You can see that benzene is now selected. I shall let you see it by shifting the pop-up window to the left. Repeat this for toluene. Let us select this. Let us add. You can see that the component selection is completed. I shall shift the window back to where it was. We are now ready to choose thermodynamics. Let us go back to the slides. Let us go to the next slide. This slide has guidelines on how to choose thermodynamics. Covering the theory behind this slide is beyond the scope of this tutorial. As benzene and toluene form an ideal solution, we can choose Raoult's law. Let us do this in DWSIM. Locate Thermodynamics tab on the left hand side. Click on it. A submenu appears in the white space above. Click on the Property Packages in the submenu. Scroll down in this list and locate an option called Raoult's law. Choose this by double clicking on it. You will see Raoult's law appearing on the right hand side of the pop-up. To see this, let me shift the pop-up to the left. On the lower right hand corner of this pop-up, locate a button called Back to Simulation. Click on it. The Configure Simulation pop-up gets closed and we are ready to do the simulation. The canvas at the center of this page is used to create flow sheets. We will now create a material stream. On the right hand side, you see an object palette. It has a large collection of many useful chemical engineering objects. You can scroll it and see what all are available. Right at the top of this is the material stream object. Click it and drag it to the flowsheet. At the desired place, remove your finger from the mouse to drop the stream. You may leave it anywhere on this canvas. You can also move the stream to another place later if required. Immediately after dropping the stream, a pop-up to enter compositions appears. Notice that mole fractions is selected by default. You can choose one of the other possibilities, but I shall leave it as it is. The chemicals that we already selected appear here automatically. Type 0.5 in the equilibrium composition of toluene. Press down arrow. Type 0.5 in the equilibrium composition of benzene. Click apply. The total of the mole fractions appears on the right hand side. If the total is not 1, DWSIM normalizes the entries so that the total becomes 1. But this may give some unpredictable values at times. So you yourself may want to ensure that the total comes to 1. Click the close button. You can always get back to the previous pop-up by double clicking on the stream. Below the configure simulation button, notice a place to change the system of units. Let us click this menu and choose CGS system. Let us now complete the specification of the stream. Click on the stream icon in the flowsheet once. Do not double click it. On the left hand side of the flowsheet, you will see the selected object window. This window consists of Properties and Appearance tabs. The Properties tab shows all the properties of the stream. DWSIM assigns default values to all properties. Let us first scroll up this page. There are many ways to complete the specification of a material stream. Press on Specification. A down arrow appears on the right hand side. Press it. The default is to specify pressure and temperature. I shall leave it as it is. I shall press the down arrow once again to close the menu. We see the number 25 already entered against the temperature. By hovering the mouse over the temperature, we see the units as degrees Celsius. Let us click to the right of this number. It is an editable field. Let me delete it and enter 30. Let us look at pressure next. I shall leave it at 1 atmosphere. Let us specify the flow rate next. We can specify mass flow rate or molar flow rate or volumetric flow rate. We will specify molar flow rate. I shall delete the old value and enter 100. Press enter to save this change. Units for this field are moles per second, as we can see now. It is possible to use a combination of units such as CGS and SI. We will postpone this discussion to another tutorial. Now the stream is fully defined. DWSIM has given the name MSTR-004 to this stream automatically. You may see some other name in your simulation, but do not worry about it. As I am not happy with this automatically generated name, let me change it. Under the selected object window, click on the Appearance tab. The Appearance tab is used to modify the visual appearance of the stream. Click on the blank space beside name and type inlet 1 after deleting this. Click on name again. You can see the name inlet 1 appearing below this stream in the flow sheet. We will build on this material stream in the upcoming tutorials. Let us go back to the slides. We go to the next slide. Let me summarize what we learnt in this tutorial. We defined a material stream, chose chemical components, chose the property estimation package, completed specifications, assigned values and units, specified temperature, pressure and flow rate, pointed out many different options. I would like to give some assignments now. Choose benzene and toluene mole fractions that do not add up to 1. Check how DWSIM normalizes when you press apply. Go to the page where you define mole fractions. Check what the normalize button does when the total is not 1. Go to the page where we define the molar flow rate. DWSIM automatically displays equivalent flow rates in other units. Check if these values are consistent. Create a stream consisting of benzene, toluene and xylene. Carry out the previous assignments for this stream also. This brings us to the end of this tutorial. This video summarizes the spoken tutorial project. If you do not have good bandwidth, you can download and watch it. We conduct workshops using spoken tutorials, give certificates. Please contact us. The spoken tutorial project is funded by NMEICT, MHRD, Government of India. We thank the DWSIM team for making it as an open source software. I want to thank you, the listener, for joining me in this tutorial. Goodbye.